take a look. NASA unveiling close-up pictures earlier today of 3I Atlas. 3I Atlas is the comet.
3I Atlas just did something no normal comet should do. Its jets stayed locked in one direction while the body turned. The frames are clear, the lines hold, the spin is real. If this stands after more nights, we are not adding a small note to a long list. We are seeing control where drift should rule. What holds those jets steady when a 16-hour spin should smear them into curves? The new line in the sky. The 12th anomaly arrived as a straight mark. A thin beam ran out for more than 1 million kilometers and refused to bend. The period of the core sits near 16 hours. Any vent on a shell that turns that fast should sweep a cone as the face warms, cools, and warms again. We should see a spiral, a fan, a soft haze that tells us where the mouth moved with time. We do not. We see a ruler line that holds. It shows up on more than one night. It appears in stacks from more than one group. The background stars give us a fixed grid. The slope of the beam against that grid stays the same within small limits. The head does not spray a wide sheet. It draws a tight track. That is why this case stands out. It fights the class rules that shape most comet frames. The length of the beam also speaks. Gas that leaves at 400 meters per second takes days to reach the far end. Days mean many turns. A 16-hour spinner rotates again and again while that flow marches out. If the vent sits on the surface, the base should sweep away from the old aim and paint a wide sheet of faint material in the far field. Instead, the far field stays tight. The line is narrow both near the head and far away. That is not how a loose plume behaves. It is how a guided plume behaves. When you add time to a guided flow, it stacks along the same axis. That is what the frames hint at here. We can set a simple test. Mark the phase of the spin as the beam points. Watch through a full rotation. If the mouth sits on the shell, the line must rock, even if the axis points near us. A small rock still shows up over a long run. If the line will not rock, then either the mouth does not sit on the shell or some frame above the shell keeps the aim. Both ideas are new for a comet. Both ideas move this object into new ground. What keeps a line straight when the base will not stay still? Why normal comet rules fail here? Natural jets rise from sun-warmed ice. Gas flashes. Dust rides the stream. The path marks the spin. We teach that rule for a reason. It fits a long list of comets. The mouth turns, the flow bends, and the sky records a fan or a spiral. The light grows when the dayside faces us and fades when it turns away. It is a simple dance. 3I Atlas will not dance. The flow speed is high. The reach is long. The far end is old in hours and days. A body that turns through many steps should sweep the mouth across new angles, while that old flow drifts out. The far field should blur. It does not. The blur is missing. The edge stays hard. Try the view trick next. If the axis of spin points along our line of sight, a sweep looks small. Yet even that case leaves a tell. Power should rise and fall as the solar angle shifts during a full turn. We should catch a slow pulse in flux along the jet. We do not. The beam holds brightness within a tight band. Now try a canyon on the face. A deep cut can collimate near the mouth. It cannot enforce a line at 1 million kilometers. The gas forgets the wall and flies free. It bends with the base spin and with wind from the sun. A far field that stays thin fights the canyon idea. The last simple escape is constant heating on one patch. That fails as well. The orbit moves, the sun angle drifts. A fixed hot spot loses aim with time unless a frame holds it for the job. We do not see a nod. We do not see a slow sweep. We see a line that acts like a thing that wants to stay put. That is the seed of a new thought. A jet that holds aim while the shell turns is not a vent alone. It is a vent plus something that fights the turn. It may be a strange set of ice and pores that act like a channel with a bias. It may be a mount that does not share the spin of the shell. It may be both. The point is not that we know which path is true. The point is that a straight mark across time forces us to test paths that normal rules do not need. That is why this event feels like a breakpoint. If the line stands under hard checks, our models must grow. We still measure heat and dust. We still count grains and fit light curves. We also watch for control. We look for clocks in the small twitch of the beam. We look for steps that repeat. We treat a jet as a tool that can be steered, not just a breath that blows. This is not a wild leap. It is a way to let the data tell us what it needs. The frame is new. The work is the same. We keep calm, test, and share. If ice and rock do not cancel spin, what does? The natural escape routes tested and broken. Start with view tricks. Line the spin axis with our sight. Place the jet right on that axis. The sweep shrinks. The drift can hide. Yet the power should still rise and fall with the solar angle. A jet that stays bright with no slow breath fights that view. Now try steady light on one patch. The orbit still shifts the sun across the face. Over days, the aim should nod. The line does not nod. Try topography. A deep slot can hold a stream near the mouth. Far out, the flow goes free. It bends with turn and wind. It spreads. It forgets the wall. What about buried vents? Suppose a chamber under the crust feeds a pipe that exits at a fixed ring above the shell. The shell turns. The ring does not. Gas leaves through the same ports each moment. That is a way to make a straight line from a spinning base. It is not a claim. It is a testable sketch. If a ring holds, a control loop leaves marks. Small repeats in aim will show up as error builds and is cleared. Feed pumps leave tiny beats in brightness. External torque from tides near a planet leave faint steps in aim that match the time of the pass. If those marks appear on time, the sketch gains weight. Now take magnetic tricks. Could dust and ions ride a field that holds a line? In the near head, perhaps. In the far field, not likely. The energy density falls fast with range. A field that's strong would leave other signs. It would twist the polarization pattern in a way that we could track. It would tie the jet to the head with a sheath that ripples when the solar wind shifts. Those ripples should drift with time like waves on a rope. We will look for them. If they are not there, the field case grows thin. We are left with two broad camps, a natural but new path that channels flow with internal order we have not seen, or a mounted system that keeps nozzles set while the mass turns. Both are rare. Both would be firsts. One rewrites ice and dust physics. One hints at work done on purpose. We do not pick by taste. We pick by trace. We ask the sky to show us small, repeatable clues that only one camp can match. The next runs must chase those small tells with strict habits, clear logs, and open files so anyone can check the path. We mark phases. We fix bands. We stack with care. We post wins and nulls. Always. If each natural trick fails in the far field, do we dare test the idea that the mount itself holds the aim? Gyroscopic jet stabilization as a working idea. Picture a gimbal that floats above a turning mass. The mass spins at 16 hours per turn. The gimbal holds its pose. Fix nozzles on that ring. Fire through the same ports all the time. The jet lines in space do not care that the base turns under them. That is the core thought. You do not have to guess who built it to test if that picture fits. Control leaves fingerprints. Reaction wheels build error and dump it in steps. Pumps push on a cadence. Thrusters kick a tiny bit when tides add or remove torque. Each of those leaves a faint repeat in the line. What should we see if a ring holds? First, small yaw events at a steady beat if a wheel saturates and unloads. They show up as minute angle twitches in a long stack. Second, micro flickers in flux at a heartbeat rate if feed systems gulp and push. Third, a gentle phase shift in aim as the object crosses a weak tide line near a planet. Fourth, near-head polarization that stays tight across a wide range if the column is truly narrow, not a fan that only looks thin. Each of these signs is faint. None are impossible to see. They ask for time, care, and matched tools. How do we look without fooling ourselves? We match bands, fields, and stack rules. We publish raw and scripts. We ask more than one site to chase the same phase. We add polarimetry and spectra, so we are not leaning on a single type of trace. We log clouds and wind and moon for each run. We repeat when the night lies to us. We do the dull work that turns a guess into a map. If the signs show up in more than one way, the map holds. If they do not, we say so, and we move on with no harm done. A ring that holds would not mean harm. The smooth line fits care, not force. It looks like clean flight through dust, not a weapon's push. The best way to cross a system is to avoid hits, limit drag, and keep control smooth. A straight jet is the mark of that art. It wastes less, it leaves less mess. It keeps the aim on task while the body turns. If that is what we saw, it says more about skill than threat. It says the builder hates waste and loves margin. We can also test with time-sliced stacks that keep 5-minute bins. If a wheel unloads on a schedule, the tiny yaw will line up with that bin width. If the flicker comes from feed pulses, the power spectrum of the light along the jet will show a clean peak. Radio silence will not rule this out, since control can be quiet. Thermal limits will not rule it out, since duty cycles can be low. What will matter is repeatable, phase-locked behavior across nights. If a clock hides in the line, will the next clear night let us hear it? What data now matter most? Clear nights are gold, but habits matter more. We need runs that match. Same filters, same field stars, same exposure plans. Mark the rotation phase in the header so we know which face we are seeing.
3i Atlas has fascinated us for months when it was first discovered. Now, is it a gigantic icy rock or possible sign of an alien intelligence?
Stack with 3 methods and compare. Share code so other teams can check your steps. Post nulls fast so no one chases a ghost. The goal is not speed, it is clean tests. The object will fade soon. The logs will live. Make them worth the time of every set of eyes that reads them. Polarimetry should sit near the top of the list. A tight, straight column keeps a stable polarization angle near the head. A fan changes that angle across its width. 2 sites with matched setups can map that change and see which model fits. Spectra close to the source can split gas from dust. A metal-rich glow would be a shock. A simple, volatile line that stays narrow would favor guided flow. Broad bands with dust edges would fit a more normal vent. These are small clues. They add up. Geometric checks help as well. Put a straight edge on the jet across nights. Measure the slope against the same field stars. If it holds, note the spread. If it moves, note the rate and where in the turn it shifts. Phase lock is a hint of control. Random wobble is not. Measure the width of the line at set ranges. A free plume widens with distance. A guided plume stays tight longer. If you can, trace faint ripples that drift along the column. Their speed pins down flow and age. Watch for outside pushes. When the path crosses weak tide lines near planets, the aim can jump a tiny bit. When the solar wind shifts, a sheath can ripple. Log those times so we can compare them with any twitch in the beam. Do not chase noise. Do not chase wishful shapes in thin data. Look for repeats that hold across nights, sites, and tools. That is how you turn one odd frame into a case that stands on its own. Community practice matters too. Use open notebooks so plots can be rebuilt. Tag frames with sky state, seeing, and moon. If a run goes bad, say it early and save others the lost night. If a run goes well, post enough for a full rebuild. Invite critics to try to break the result with fresh stacks. If they can, we learn. If they cannot, we gain ground. This is how small teams can match the weight of big scopes. We trade reach for rigor and let time work for us. In the end, the test is simple. Do straight lines, survive full turns, and full checks. If yes, our map changes. If not, we move on. We learn anyway. If the line stays when we do the hard, dull work, will we let that truth change our minds? If it holds, what then? If fixed jets survive the checks, 3i Atlas becomes a first in our records. A line that will not bow to spin means a new rule is at work. That rule might live in strange ice that channels flow and cancels turn by itself. That rule might live in a mount that keeps nozzles set while the mass turns. One path rewrites comet physics. One path reaches beyond. Both paths ask us to change how we look at lines in space. The natural path would open a class of interstellar bodies that carry layered pores and veins that act like valves. Heat would open them in ways that steer flow back toward a single aim. The pattern would be rare, but the rules of pore size, pressure drop, and fracture angle could be learned. Lab work could copy it in cold chambers. Sim runs could teach us which shapes keep a steady aim. We would add new terms to models that now treat jets as simple vents. The mount path would say, we just saw control. A gimbal, a ring, a torus, or some other frame that holds pose while the body turns. It would not have to be large. It would have to be stable and smart in a quiet way. The smooth line fits low waste, low drama flight through dust. It fits the art of moving without harm. It would raise new questions we can test. How long did the aim hold? Did it hold across tides? Did it hold across the wind? Did it hold across days and nights? Either way, our practice changes. We stop treating a jet as a blur and start reading it as a path with memory. We ask for clocks in the trace. We hunt for beats. We listen for soft rhythms in light and in shape. We treat a straight mark as a signal to be decoded, not just a pretty thing to share. We teach the next class that control can hide in plain sight, and that patience and clean methods are the tools that bring it out. This does not demand belief. It demands care. The sky does not owe us answers. It gives us hints when we work with respect. If this line stands, we will have a new page in the book of things that cross between stars. It will be one that tells us to balance doubt with nerves. Doubt keeps us from fooling ourselves. Nerve keeps us from closing the door before the truth knocks. And if a second straight mark comes after this one, we will have a pattern. Patterns force change. They make even the most careful minds move. That is how fields turn. That is how new tools are born. That is how we grow. If this is our first straight mark from the deep, what will we do when the second one arrives and we have no excuse to miss it? The next week will decide this. We watch for straight beams that hold through full turns. We listen for tiny beats that repeat on a clock. We match spectra and polarimetry near the head. If those hold, this is not an upgrade. It is a reset. Want to see it happen in time? Subscribe, tap the bell, and drop the one question you want answered first. Are we seeing a comet that tricks us, or a craft that teaches us?